Yes, today we are going to explain this problem. Um, its rating is 1600 and is posted by Rahel, right? So as always, we are going to introduce this problem by explaining the example here, right? So let's see the example. We have two numbers in the input, n on the left, m on the right, right? And we are going to create two arrays, and the final answer is the number of ways to create these two arrays, right? And these two arrays have to satisfy these conditions. So the first condition is that the length of both array is equal to m, right? So we have two numbers in both of these arrays. And each element of each array is an integer between 1 and n, right? So for these numbers, we're going to choose from 1 and 2, right? And ai is small or equal than bi for any index I from 1 to m, right? So um, um, for this index, this guy should be bigger than this guy. And for this index, this guy should be bigger than this guy, right? And um, array A is sorted in non-descending order. So this array is non-descending, right? And this array is non-ascending, right? This array is non-ascending. So we can dive deep here, right? So this guy is maximum value in A array, right? And this guy is the minimal value of the B array, right? Because it's non-ascending, right? So this minimal value of array B is bigger than the maximal value of array A, which means all of these numbers are bigger than all of these numbers, right? Because the minimal number of this number is bigger than the maximal of these numbers. So as long as the number is in this array, it should be bigger than any number in this array, right? So we are going to construct the two arrays, and we need to count how many possibilities are there, right? Let's say we have 1 and 1 in the first array. What can we have in the second array? We can have 2, 1, right? So these two arrays satisfy all these conditions, right? And also we can have 1, 1, 1, right? And we can have 2, 2, right? Um, Actually, we are not going to write all of them, so you can find out yourself, all right? So let's move on. So how to solve this problem? Usually for the combinators problems, we are going to use dynamic programming, all right? So the most important part of dynamic programming is find the states and find the formulas, right? So let's see the definition of the states in this problem, right? So the first state is F. And what's the definition of F? It's a number of arrays that has I numbers and end with J. What does that mean? So let's say uh, we want to calculate F21, all right? So um, so F21 means the number of arrays that has two numbers, right? And end with 1, right? So we have two slots here. We have two slots here. And it ends with 1. So we fill the second slot with 1, right? So what can be put into the first slot? We have only one option, that is put 1 here, right? So F21 equals to 1 because we only got one possibility. So F21 is 1, right? So what about F22, right? So we got two numbers and end with 2, right? So we got two slots to fill, and the second slot is 2, right? What can we put in the first slot? We can put 1 here, right? And we can also put 2 here, right? Because the because the array are sorted, so the first number should be smaller than second. So we have two options here. So F22 equals 2, and we can put a 2 here, right? And let's move on. What if we want to calculate 2, 1? I mean 1, 1, right? So we are going to have one number and end with 1, right? So obviously we just got one possibility, right? What about 1, 2? So we have one number and end with 2. So obviously also we got only one option, right? So that's the definition of Fij. And what is how do we calculate Fij? We use this formula, right? So let's say we have I numbers. So we have um, I numbers here, right? I slots to fill, and end with J, right? So we put a J into the last slot, right? And what's the prefix of this array? For this part, we have I minus 1 slots, right? So what can we put here at the second last place, right? We can put a 1 here, right? As long as it's smaller than J, right? We can also put a 2 here, and we can go all the way up to J minus 1. J minus 1 smaller than J, right? And we can put a J here. J equals to J. So of course we can put a J here. So the possibility of um, the we put a 1 here, the possibility is happens to be fi minus 1, 1, right? Because it ends with 1. And these guys can, each of these guys can find a correspondent here, right? This guy corresponds to this guy. This guy corresponds to this guy, right? And this guy corresponds to this guy. So if we put j as the second last number, we are going to have this number of possibilities, right? So we add them together, we get the possibilities of Fij, right? So we can further transform this formula because we find out that this guy happens to equal to this guy, right? Because we can take a look at this formula again. If we replace j with j minus 1, we got this guy, right? Because so that being said, this guy equals to this guy, right? So we can transform this part into this part. And the final formula is this guy, right? So Fij would be very easy to deduce from these two numbers, right? And we can move on to another definition, which is G, right? G means the number of arrays that has I numbers, and the numbers are all smaller and equal. Sorry, I missed that. Or equal than J, right? So for example, if we want to calculate G to 1, right? We are going to have two numbers, right? Two slots to fill. And all of the numbers are small or equal than 1, right? So we can only put 1 into these two slots. So G to 1 equals to 1, right? Only one option here. How about G to 2, right? So we have two numbers and all of the numbers are equal and small or smaller than 2, right? So we have two numbers and we can put a 1 and a 2 in this array, right? So we can put 1 1 here, 1 2 or 2 2, right? Three options. So G to 2 equals to 3, right? So let's move on to the formula here. So I hope everyone understands the definition here, right? So that we can move on to the formula. So let's say we want to calculate G, I, J, and we have I slots to fill, right? And all of those slots, all of those numbers should be smaller than J, smaller or equal than J, right? So for the last number, we can have J, right? And we can also have J minus 1. because the last number is the maximum value of this array. So if this number is j minus 1, this number are all going to be less or equal than j minus 1, right? So all of them will be lesser than j, right? And we can go all the way down to 1, right? If we have 1 as the last value, all the numbers before it should be 1 as well, right? So we can add all these possibilities together, right? And the possibility of this guy happens to equal to fi1, right? Because we have I slots and the array ended with 1, right? And we can find out all of their correspondence, right? For example, this guy, we have I numbers and ended with j minus 1 equals to this guy, right? And this guy equals to the possibilities of this kind of array equals to fij, right? And just like before, this part happens to equal to this part, right? Why? Because if we replace j with j minus 1, right, we will not have these two guys, right? J minus 1, right? So this guy equals to this guy. So we transform this part into this part, right? And this guy is still this guy, right? So we can get a simpler formula here, right? Gij equals to Gi j minus 1 plus Fij, right? Very simple. We got two very simple formula, and I we can assume that we can calculate all those values of f and j, right? After we got all of those f and j's, we can calculate the final answer, right? So the final answer here is to first find the, let's say, the maximal value of the first um, array is max a, right? So we can iterate it from 1 to n. So let's say we put a 1 here. So what's the possibilities of the first array? What's the number of possibilities of the first array? It has two numbers and ended with 1. So if it's f11, right? f21, I mean. So it happens to be this guy, right? And the number of possibilities of the second array is this guy, right? And we can multiply them together to get the total number of possibilities of constructing these two arrays, right? And we iterate the maximum value of the array A from 1 to n and add them together to get the final answer, right? So let's take a look at the code. So the code is here. So um, after we cleared out the ways to calculate the f and g's, the code is very trivial, right? So this is the initial value of f, right? Because fij all equals to 1, right? If we only have one number and it ends with j, we can always get one option, that is put the j into this slot, right? So all of these f's equals to 1, right? And we can calculate the rest of the f's, right, in this way. And we can calculate the rest of the g's in this way, right? And we can calculate the final answer in this way, right? So the code should be very trivial for dynamic programming problem, but the how to find the state and how to find the formulas is not that obvious in those problems. All right. So I hope it can help you to solve this problem. So have a great day. Thank you for watching. Bye bye.